Hello everyone. Today we are going to solve a question that asked in TIFR Mumbai, written exam in 2022. Okay, and we will solve this problem in very detail. Okay, and from theoretical part to the solution part of the question. Okay, तो चलिए शुरू करते हैं. तो उसके लिए पहले हम लोग जानेंगे कि मीन वैल्यू थ्योरम फॉर इंटीग्रल कैलकुलस क्या होता है. What do you mean by mean value theorem for integral calculus? Everybody we know about mean value theorem for differential calculus, right? Now we'll learn about something called mean value theorem for integral calculus. So there are mainly two mean value theorem for integral calculus, right? One of the is first and second. First integral calculus and second one is called Bonnet form. Bonnet form integral mean value theorem for integral calculus. Okay, the first thing that I want to give that जो है वो है क्या, the first mean value first mean value theorem for integral calculus. Integral calculus. Okay, integral calculus. So first we will discuss about the theoretical part. What do you mean by first mean value theorem for integral calculus? Then we'll solve a generalized problem, and that in that generalized problem we can sort out the problem that asks in here. Okay, so we will go from the basic. Okay, now okay, so that is the first mean value theorem for integral calculus. Okay, so that is first MVT for IC. Okay, IC means integral. Yes. Okay. So first that we don't put that theorem. Okay, I just give the statement of the theorem. Okay, so let me give that. Now let F and G both are functions from A B to R. Both are integrable. Okay, both are integrable. Say for G two functions from closed interval A B to R. So both are integral functions. Okay, that is given. And first condition that G of X has same sign. G of X has same sign on closed interval A B. Right. That is the crucial point of that theorem. First, that is the second condition. First condition is they both are integral. First, both are integral. First condition, both are integral functions. Integral functions. Okay. Both are integral functions. First condition. And second condition, that most important thing is that g of x has same sign on closed interval A. Same sign means if it is positive, then it is positive throughout the interval. If it is negative throughout the interval. Okay, that is the statement of that first mean value theorem. That is the hypothesis. I have not concluded yet. Okay, so first f and g both are integral function and g of x has to be the same sign throughout the interval. Same sign means if it is positive, then throughout positive. Means if it is either positive on the interval or it is negative throughout the interval. That is the meaning of that it has same sign over the interval. Close interval. Okay. Then, 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 then there exists a there exists a mu such that, such that, there exists a mu such that, such that small m less than equal to mu less than equal to capital M, where small m is the infimum of f of x, where x belongs to closed interval a. Okay, okay. And capital M is the supremum of f of x, where x belongs to a. Clear? X belongs to a. Okay. Yeah, so such a m, small m and capital M exist. Why? Because integrable function in Riemann integrability functions assumed to be bounded. Okay. In that, if you know something about Riemann integrability, you know that that functions assumed to be bounded functions on the closed interval, closed and bounded interval AB. Okay. Yeah. So from that, this M and M exist, and this mu exists between small m less than equal to mu less than equal to capital M. Okay. Yeah. So with, 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 let me go now. With that integrable integration between a to b f of x g of x dx is equal to mu of integral a to b g of x dx. Okay, clear? Is that problem clear? Okay. Is the problem clear? Yeah. So first, we'll show that that is the first mean value theorem for integral calculus. That if you are given two Riemann integral function, okay, now one of them has the same sign throughout the interval. Then you want to compute their integrability of the product. So how do you compute? Well, that is that there exists some number, there exists some number mu, there exists some number mu such that small m less than equal to mu less than equal to capital M. Okay. Small m less than equal to m capital M, and uh, capital M, M is the infimum of the function and capital M is the supremum of the function. Then we can tell about that integrability. Okay, so the integral a to b f of x g of x dx, it is mu times the integrability of the non changeable, non-sign changeable function. Okay, that its signs should be same. Okay, so that is what we want to go and okay. Okay, that is our first mean value theorem. Now we will try to solve a problem depending on this. And this problem is the generalization problem that asked in TIFR Mumbai in 2022. Okay, so let me write that problem in bit detail. Then we will discuss that problem solution. Okay, so that first thing, that question is that let if close interval 0, 1 to R be a continuous function. Be a continuous function. Okay. Okay. So if from closing interval 0, 1 to R, it is a continuous function. Okay. Then, then compute, then compute the limit. The limit. We have to compute the limit. Which limit? Yeah, that we will discuss. That limit n tends to infinity 0 to 1 in f of x dx upon 1 plus n square x square. Okay, in that way, yeah, we confused you. Yeah, that that is okay. Yeah. So we have to find out that limit. Okay. We have to find out that limit. What will be the limit of that uh, function in terms of integral? Okay. So so first of all, just you see that f is given to be a continuous function over the closed interval 0. Okay. So now if we look at that first mean value theorem, what it says? It says that two integral function. Now continuous functions are also integral. If f is assumed to be in that first mean value theorem, if f is continuous, then if f is continuous, okay, if f is oh, let me no, right, that is g of x, right? That already written there. That is g of x. Okay. Now we'll discuss. Now, if in the statement of first mean value theorem, if f is continuous function, that mu is something to be some functional value of some points of f, right? That mu should be f of c or f of b or f of something where c belongs to closing double a. Okay. That because by IVP, that mu value will be attained. Okay, so that is our remark in the problem. So we don't bother about that. Now we will solve this problem. Now we will solve this problem. So to solve this problem, we have to write the solution. So first write solution. Okay, so we will write the solution of the problem. Okay, now take that f is a continuous function over the closed interval 0. Right. Since f is a continuous function over the closed interval 0, 1, so uh, continuous image of complexity is compact, so its image should be bounded. So supremum of that function is exist. So let's take m be the supremum of f of x where x belongs to closed interval 0, modulus of it. So, so I'm taking that m should be positive. I'm taking, okay, m the supremum. I'm taking that m in the supremum of modulus of x belongs to 0. And this exists. This value exists. This value exists. And, right? So, continuous image of complexity is for complex. So this value exists. Okay. So this value exists. First of all, by continuous image of complexity that I'm discussed in earlier videos. Okay. Now I just want to know what about this term? What about this term? n 1 plus n of x, this term. What about this term? n 1 plus n square x square. This term is always positive, right? Whatever x you take from close interval 0, right? Close interval 0. So this term n upon 1 plus n square x square is always positive for all values of the total. Okay, that is always positive. So now that hypothesis of the first mean value theorem for integral calculus is satisfied here. Okay, but now I just want to know think about this. So what can you write this? 0 to 1 n. Let me write slowly. That is n f of x upon 1 plus n square x square dx, that is equal to 0 to 1 by root n in f of x 1 plus n square x square dx plus 1 upon root n 1 in f of x by 1 upon n square x square dx. Okay, we can write it because for any n, square root of n is always greater than equal to 1. So 1 upon square root of n is less than equal to 1. So that 1 upon square root n is in between 0 to 1. Okay, so we can take that. Okay, now I'm just taking this. This is the integral number of I1, and that is integral number I2. If I am to compute this, okay, integral of I1 and I2, because I want to know where it goes when n tends to infinity, right? So we want to explore more about that first integral. Okay. So, and in first integral, both if is continuous, this is also continuous. So both are integral, and this sign, this part n by 1 upon n square plus x square, this part has positive sign, right? It has positive sign. So it has positive sign. Then we can apply the first mean value theorem in both the integrals, to the both the integrals. Okay, to the both integrals. So this integral also and this integral also. So we'll give that first thing to this one. Okay. Now take that. So right. Let me write that first integral I1. So that is 0 to 1 upon square root of n f of x upon 1 plus n square s square dx. Okay. Now, just use from this step to this step. Use the first mean value theorem. Okay, first mean value theorem. By first mean value theorem, you can see that that is f of alpha n. That is f of alpha n 0 to 1 by 1 by square root of n upon 1 plus n square x square dx. Okay, dx. Okay. Now, where alpha n less than equal to 1 by square root of n and greater than equal to 0. Because by mean value property, and since f is continuous, then that mu is attained here. Okay, let me show the that I am taking. That here mu, and this mu is belongs to uh, in between infimum and supremum objects. Okay, and that mu is attained because of the continuity of f, because of continuity of f. Okay, so that mu is attained. So that mu is attained due to alpha n. Okay, for defined I am taking getting a defined alpha n. Okay, what type of n you are choosing? Now, I'm just you will use the substitution method here. Okay. How do you substitute that? Take 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 u equal to nx. Okay. Then du will imply du equal to n dx, because n is fixing in that. whole calculation. Okay. So uh, now we'll get to that f of alpha n, and for limits of x, what do we know about limit of x? If x has limit 0, 1 by square root of n. So for u, the limit will be 0, it's 1 by root n, so that will be root n. Okay, so that limit will convert it to 0 to square root of n, and n dx will be substituted by du, and nx will be substituted by this. After uh, doing this calculation, we will get f of alpha n and t square root of that is tan inverse u. Okay, tan inverse u, integration of because it is the integration of tan inverse u, and that is 0 to square root of 1, because it's the calculation of class 11 and 12. Okay, in 12 student we have done lots of calculation like this. So that is f of alpha n, that is tan inverse square root of n, and tan inverse 0 is 0, so I am not writing this. Okay, that is the product. Now think about that. By Sandwich number, 0 goes to 0, this sequence. 1 by n, square root of n, this goes to 0 as n tends to infinity. As n tends to infinity, alpha n goes to 0. Okay, and since f is continuous, since f is continuous, so f of alpha n goes to f of 0 as alpha n goes to 0, as n tends to infinity. Okay. Okay. Yeah, as when n tends to infinity, alpha n goes to 0, then f of alpha n goes to f of 0 by sequential criteria of continuous function. Okay. And as n tends to infinity, tan inverse square root of n, this will run to pi by 2. Okay. So this limit goes to pi by 2. That means pi upon 2, pi upon 2, and f of 0. F of 0. Okay, so first integral we have computed as n tends to infinity. So then the first integral I want will goes to as n tends to infinity, that would be that pi by 2 f of 0. Pi by 2 f of 0. Okay. Pi by 2 f of 0. Pi by 2 f of 0. Yeah, you know that first condition is. Now, now we will solve the second one, second integral. Second integral, that is I two. Second integral is I two. Okay. So for that second integral, we will do something calculated, that for second integral, that integral is okay. So solve that, that is square root of 1 by n to 1 n f of x upon 1 plus n square x square dx. Okay. Yeah. We'll solve this problem again thoroughly. In the same pattern. In the same pattern, what we can do, so we can do one more thing, that we just take the modulus of that. Okay. Take the modulus. Why we will see later. So modulus of this integral will be less than equals to 1 to square root of n, 1 n modulus of f of x 1 plus n square x square dx. Okay, and and this coming from some properties of Riemann integral. The modulus of integral is less than equal to integral of modulus. Okay, that is clear. And this f of x is less than equal to. Okay, so no, I am not thinking about this modulus thing. Okay, now but use by then by second again by first mean value theorem, that should be something f of beta n. Okay, that should be some f of beta n, right? For some beta n, and beta n, that beta n is then equal to 1 greater than equal to the square root of 1 by n. Okay, for some beta n. The beta n that comes from the first mean value theorem of इंटीग्रल कैलकुलस. ओके, नाउ तो अभी देखना है कि इसको कैसे सॉर्ट आउट करें. ओके, सो नाउ थिंक दैट दैट मॉड्यूलस ऑफ एफ ऑफ बीटा एन and that just calculate these things again. Okay, calculate these things by substituting nx by u and just do the thing. Then we'll get something, because x for x limit and u limit. For x limit, it is 1 by square root of 1 by n 1. And uh, nx equal to u. In that time, it is square root of n and n. So that is that integral again to be n to square root of n to n. Okay, and then this will become du 1 plus u square. Okay, now we'll just solve it. After solving it, it will become that it will become that if the it will become that f of beta n, and that is tan inverse n minus tan inverse square root of n. Okay, and modulus of this. And this modulus f of beta n, this is less than equal to m, because we have assumed to be the supremum of modulus of f of x is m. Okay, so this modulus is less than equal to b m dot tan inverse n minus tan inverse square root of n. Okay, and as n tends to infinity, this will goes to 0, because as n tends to infinity, this is tan inverse tan inverse uh, n tends to infinity, that is pi by 2, and this is also pi by 2, cancel out, that will be 0, because their limiting is finite, and your pi by 2 minus pi by 2 is 0. So that I2 becomes 0. So after computing all those things, we will by adding up to these two things, we are getting that limit n tends to infinity integration 0 to 1 n f of x by 1 upon n square x square dx, that is pi upon 2 f of 0. And in the question of TIFR that is asked, the question is asked about that. Now let me give me the question of that. Uh, okay, this question is asked. This question is asked in TIFR 2022. Okay, and here f of x is given exponential x. Then f of 0 is 1. Then the solution will be pi by 2 f of 0, that is pi by 2 dot 1, that is pi by 2. Okay, so the solution will be pi by 2, the option. Okay, that we have solved it. Okay, thank you for watching this video.